Hi, welcome back to our next set of notes. Now, for this next lesson, it is essential that you have a graphing calculator. And that is simply because you are unable to do this type of process or this type of procedure without a graphing calculator. You can't do it on a scientific calculator and you can't do it on your cell phone calculator. It has to be a graphing calculator. So if you are unable to get one, I need you to personally reach out to me and we can kind of come up with a plan. Typically at school we have a rental program, but we can't do that since we're obviously not at school right now. But it was something that was under the syllabus, and we had mentioned it within the first week, I know at least a couple of times, and we talked about what it looks like. So again, this is a graphing calculator. You're expected to have a TI 83 or an 84. Those are the two that work the best together, and the steps are exactly the same for 83 or 84, okay? And so those are the calculators that we use here at Sumner, from Algebra 2 and beyond, as well as in college, they use the graphing calculator. So it's a good investment, but yes, it is a pricey investment. So go ahead and make sure to look at Facebook Marketplace or anything like that. You can get one cheap, but if you can't, reach out to me, okay? So we have our fill in the blank notes, which I realize a little bit easier when you can actually fill them in. So I realize that you'll have to do a bit more writing if you do not have access to a printer. And so I apologize for the setup of that, just because in class typically we'd print these for you. Okay, so what is a scatter plot? So you all should be familiar with a scatter plot. It is a graph that relates two sets of data using ordered pairs. Okay, a graph that relates two sets of data using ordered pairs. Okay. Well, the next thing we're going to talk about is correlation. Now, this is something you might not know about, kind of depends. But correlation is the strength of the relationship between data sets. Okay, so how strong is the data? Okay, and so there's actually 5 different types of correlation, and we're going to go through those now. Now, I've already filled in my examples here on the first page just because it takes so long to draw. Just go ahead and pause where you need to. So here's the first row. So the first type of correlation we're going to talk about is positive correlation. So positive correlation is when you have data that's increasing from left to right, okay? Following that positive slope look, okay? So with positive correlation, we have strong and we have weak. Now, what makes it strong and weak? It depends on how close it is, okay? So as you can see here, my data is so much closer together, okay? They're very close together. Over here, the data is still positive, but it's a little bit more spread out, okay? It still has that positive direction, but it's just a little bit spaced out, okay? Now, what can we use? Oh, I didn't fill in this bubble, my bad. Now, what we use in our calculator to help us judge our correlation when we're doing the calculator steps is something called the correlation coefficient. And I'll have something down here to write for that in just a second. But it is R in the calculator, a lowercase r, and it indicates how strong or weak correlation is. So when we're looking at a strong positive correlation, our R would be between 0.7 and 1. Now, 1 is perfect, 1 is amazing, but we don't live in a perfect world. So you're going to see 0.9, 0.99, 0.99999, okay? Very, very, very rare is there ever 1, because obviously it has to be extremely perfect, exactly perfect. Now, for weak positive, it's going to be a little bit less data that's strong, right? So it's, or a little weak, obviously. So 0.4 to 0.7 is kind of your range for weak positive. Now, are these exact numbers? Does it always mean that it's weak or positive if it's these numbers? No, but that 0.7 is really that bubble. So it's like, is it positive? Is it weak? So that's kind of a middle ground, right? But obviously if it's down in the 0.4, 0.5, yeah, that's pretty weak. If it's in 0.8, 0.9, that's really strong, okay? So 0.7 is that really that middle ground. Okay. The next one we have is no correlation. Okay, now that's when the data is everywhere. It doesn't make sense. It doesn't even relate to each other. Okay, how can the color of your car be compared to the color of your eyes? Just because I have a blue eye doesn't mean I drive a certain car, right? So no correlation. The data has no purpose to each other. So we have, in this situation, 0 to 0.4, and then a little hint, there's going to be negative correlation. So it also means if you have negative 0.4 to 0, okay? And we'll talk about that in just a second. But 0 is the worst. So 1 is perfect, 0 is the worst. So as you can see, as the numbers decrease in the positive sense, then you're getting less and less correlation that is strong and positive, okay? Now, on the other side of things, we have negative correlation. So it's going to be the exact same situation as the positive. It's just now decreasing from left to right, just like negative slope, right? So we have close together points, and we have just slightly further away points. Okay? And then because it's negative correlation, that means your correlation coefficient, R, is going to be negative, okay? So we have negative 0.1, or sorry, not 0.1, negative 1 to negative 0.7. And then for weak, we have negative 0.7 to negative 0.4. And then, like I said, back up here, negative 0.4 to 0, okay? So, but it's a little harder to think about that because technically negative numbers, as they're getting closer to 0, are getting bigger. But just think about it in the terms of those groupings, okay? And again, negative 1 would also be considered perfect. So as it gets closer to 1 or negative 1, it is perfect or great data. When it's close to 0, it's not great. There's literally nothing that's going to help us be able to give strong data against something that has a correlation of 0 or close to 0. And then last but not least, I did say I was going to have something here in writing. Oh, my eraser's blocking this. R is the correlation coefficient. And again, that tells us how strong the correlation is between the data. And that's a number that's going to be provided to us on our calculator once we start the calculator steps. Okay? So go ahead and take these notes, and I'll see you in the next video.